Whether we're doing it by hand or with computer, what we're figuring out is the maximum length the flooded section can be before the margin line hits sea level. Once we've done the calculation for one part of the ship, we repeat it along the centre length. As you'll notice, it takes more water for the margin line in the middle to touch sea level. That's because it takes less water to bring the margin line down at the front and back of the ship because of the trim. Flooding near the centre causes the ship to sink straight down with little to no trim. Once we've done this for the entire hull, we get what's called the floodable length curve. If the floodable length at a certain point is, say, 10 metres, that means the length of a compartment centred there needs to be less than 10 metres. Otherwise, a breach at that spot could make the deck go under. There's a simple way to check this on paper, even without a computer. Take the floodable length curve and draw a vertical line from the centre of a compartment equal to its length. If that line stays below the floodable length curve, then the compartment is shorter than the floodable length at that point. To put it another way, if the compartment is 8 metres wide between bulkheads and the floodable length curve above the centre of that compartment is 10 metres, this tells us that even if this compartment gets breached, it won't sink the ship. What we've discussed so far is part of what's called damage stability, which focuses on how the ship behaves after an accident. For a long time, this didn't get the attention it deserved. And then, the Titanic sank.